Hey guys, welcome back. Now we will study the second chapter, which is the origin and the evolution of the earth. You're all curious, right, about the origin of the earth? So now let's study about it. So one of the earlier and the popular arguments was by German philosopher Immanuel Kant. This argument was later revised by Laplace. It is known as the nebular hypothesis. It considers that all the planets were formed out of a cloud of material which was associated with a youthful sun which was very slowly rotating. But in 1900, Chamberlain and Moulton they considered that a wandering star approached the sun, and as a result, a cigar-shaped extension of the material was separated from the solar surface. As the passing star moved away, the material separated from the solar surface and it continued to revolve around the sun and it slowly condensed into planets. So later, this was supported by Sir James Jeans and Sir Harold Jeffrey. But again, at a later date, there were arguments which considered that the sun had a companion. These arguments are called the binary theories. In 1950, Otto Schmidt and Carl Weizsäcker they somewhat revised this nebular hypothesis. They considered that the Sun was surrounded by solar nebula, which mostly had, as you know, hydrogen and helium, along with a little dust. The friction and collision of particles it led to the formation of a disk-shaped cloud, and the planets were formed through the process of accretion. So initially, nebular hypothesis, they said there's a what do you call a cloud of material and another star approached sun and hence a cigar shaped material was separated from the sun and it began revolving around the sun which was then called planets. But at a later date these two people Otto Schmidt and Carl Weizsäcker they revised this nebula hypothesis and they said that no star approached the sun. It was the friction and the collision of the particles in that cloud only which led to the formation of planets. Okay, so this is the origin of the earth. Now, these were all very early theories. Now, let's come to the modern theories. In the modern theories, the very popular argument for the origin of the universe is the Big Bang theory. This is also called as the expanding universe hypothesis. Okay, this was proposed by Edwin Hubble. He said that as time passed, the galaxies kept moving further and further apart. So, now let's talk about the Big Bang Theory. In this Big Bang Theory, first, in the very beginning, all the matter forming the universe, it existed only in one place in the form of a very tiny ball with very small volume, very high temperature and very high density. And at the Big Bang, that moment, this tiny ball, it exploded very violently. This huge explosion took place. Now, we say this took place exactly 13.7 billion years ago. And due to that moment, till date, the expansion is still continuing. So, as it keeps growing, some energy, as this explosion took place, so slowly everything was getting scattered. So, as this kept growing, this kept expanding, some of the energy was converted into a matter. So, slowly the expansion has been slowing down. Within the first 3 minutes from the Big Bang event, the first atom began to form. And within 3 lakh years from the Big Bang, temperature dropped to 4500 Kelvin and gave rise to atomic matter, and the universe became transparent. Now, there is another alternative theory to this Big Bang theory, which is the Hoyle's concept of steady state. This concept considers the universe to be roughly the same at any point of time. It rules out the possibility that the universe is expanding. Okay, so now this is the modern theory for the origin of the universe. So we have seen two theories. One is the early theories and the modern theories for the origin of the universe. Now let's see the star formation. Okay, so in the early universe, this matter and energy, they were not very uniformly distributed. So because of these initial density differences, it gave rise to differences in gravitational forces and it caused the matter to get drawn together. This formed the basis for the development of galaxies. A galaxy is basically the one that contains a large number of stars, and these galaxies spread over vast distances. A galaxy starts to form by accumulation of hydrogen gas in the form of a very large cloud called nebula. Okay, guys, do you know that what is a light year? It is nothing but the distance that the light will travel in 1 year. Now, you know the speed of the light is 3 into 10 power 8 meter per second. And you know what 1 year is? 365, 1 by 4 days. So now if you multiply both of them, you will get the distance that the light will travel in 1 year. And you will get that to be 9.461 into 10 power 12. Now, the mean distance between Sun and Earth is 149 into 10 power 6 kilometers. If you calculate that distance in terms of light years, it is 8.311 minutes. Okay, now we'll talk about the formation of planets. So now we already studied that there were few localized lumps due to density differences and they formed stars. Now even within the stars, there were some localized lumps of gases and due to the gravitational force, these lumps, they led to the formation of a core to the gas cloud and the huge rotating disk of gas and dust developed from that gas core. So in the next stage, this gas cloud slowly started getting condensed and, and it resulted into small rounded objects. These small rounded objects, by the process of cohesion, they developed into planetesimals. Larger bodies start forming by, so in the final stage, these planetesimals again combine to form planets. Okay. Now let's talk about our solar system. Our solar system, you know, it has 8 planets, and it began forming some 5 to 5.6 billion years ago, and the planets were formed about 4.6 billion years ago. Now, out of the 8 planets, Mercury, Venus, Earth, and Mars are called the inner planets. They lie because they lie between Sun and the belt of the asteroids. And the 4 planets are called the outer planets. What are those 4 planets? The rest: Jupiter, Neptune, Saturn, Uranus. So, the first 4 planets are Earth-like. So, they are called terrestrial because they are made up of rocks and metals and they relatively have high densities. The rest 4 planets, they are called the Jovian planets or gas giant planets because Jovian means Jupiter-like because they are like Jupiter. They are mostly larger than these terrestrial planets. They are very thick atmosphere, mostly made up of helium and hydrogen. You know that till very recently, Pluto was also considered a planet. However, in a meeting of the International Astronomical Union, a decision was taken that Pluto may be called a dwarf planet. Now, let's talk about the differences between terrestrial and jovial planets. Firstly, these terrestrial planets, they were formed in the close vicinity of the parent star, where it was too warm for gases to condense to solid particles. while these Jovian planets were formed at quite a distant location. Second, solar wind was the most intense, where obviously very near to the sun. So it blew off lots of gases and dust particles from the terrestrial planets. That is why we have mostly rocks, we don't have much of gas. But in the distant planets, obviously the solar winds are not intense and they cannot blow all of that, and hence gases are there. And the third is that the terrestrial planets are comparatively smaller, and so their lower gravity, it could not hold the escaping gas. Now, now let's talk about the moon. The moon is the only natural satellite of the Earth. Sir George Darwin, he tried to explain the origin of the moon. He suggested initially that Earth and Moon formed a single rapidly rotating body. The whole mass became a dumbbell-shaped body and eventually it broke. And there was also one more suggestion that the material forming the moon was separated from what we have at present, which is the depression occupied by the Pacific Ocean. However, the present day scientists they do not accept either of the explanation. They accept that the moon is an outcome of a giant impact, or what is described as the big splat. A body which is around 1 to 3 times that of Mars. It collided with the Earth very shortly after the Earth was formed. This portion of the blasted material then it continued to orbit the Earth and eventually it formed the present day moon. So moon was formed around 4.44 billion years ago. Now, evolution of Earth. Earth has a layered structure. The outermost end of the atmosphere to the center, whatever material exists, it's not uniform. The atmospheric matter, it has the least density. Now, the next topic. Now, evolution of lithosphere. The Earth was mostly in a volatile state during its primordial stage. Due to gradual increase in density, the temperature inside has increased. As a result, the material inside started getting separated depending on their density. So heavier metals sink towards the center of the earth and the lighter ones they move towards the surface. With the passage of time, it cooled down and it condensed into a smaller size. So the outer surface developed into a crust. During the formation of the moon, due to that giant impact, the earth was again further heated up. So it is through this process of differentiation that this earth forming material it got separated into various layers, which is called the crust, mantle, and core. In core we have inner core and outer core. So from the crust to the core, the density of the material increases. Now there are three stages in the evolution. Now there are three stages in the evolution of the present atmosphere. The first stage. The first stage is marked by the primordial loss of primordial atmosphere. The second stage is that the hot interior of the earth contributed to the evolution of the atmosphere. And finally, the composition of the atmosphere it was modified by the living world through the process of photosynthesis. So, in the early atmosphere, what happened was it had a lot of hydrogen and helium. Now, this was stripped off only because of the solar winds. And next, in the next phase, which is, and in the next phase, during the cooling of the earth, the gases and the water vapor, they were slowly released from the interior solid earth. So slowly started the evolution of the present atmosphere. The early atmosphere, it mostly contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little oxygen. The process through which the gases were outpoured from the interior is called degassing. Continuous volcanic eruptions contributed water vapor and gases to the atmosphere. So slowly as the earth cooled, the water vapor release started getting condensed. The carbon dioxide in the atmosphere got dissolved. The carbon dioxide in the atmosphere got dissolved in rainwater and the temperature further decreased. causing more condensation and more rains. And this rainwater, which fell on the surface, it got collected in the depressions to give rise to oceans. And the Earth's oceans were formed within 500 million years from the formation of the Earth. But around 2500 to 3000 million years before the present, the process of photosynthesis got evolved. Before that, life was confined. No, no, it got evolved and life was confined to the oceans for a very long time. Now we'll talk about the origin of life. So, modern scientists they refer to origin of life as a kind of chemical reaction which first generated very complex organic molecules and it assembled them. This assemblage was such that they could duplicate themselves, converting inanimate matter into living substance. And here ends the first chapter. I'm sorry, the second